This is Michael from Between the Borders again, and I was actually originally going to set up to do some signals intelligence, determining wavelength from radar aperture. But this came up, and frankly, this had less image work I needed to do, so it came out quicker. This is touching on the previous thing we had, but this is aircraft survival analysis. It's more fundamental. I just used the aircraft because we'd previously discussed it, but this works for everything from power generation to keeping your computer cool. This is everything about risk and how to take a look at what actually matters and the changes that you can make. Taking a look here at the B-17. Now, before I realized we weren't actually using a B-17, but that was the original discussion, was the B-17 as a platform determining what would and would not shoot her down. I was going to say sink her, but that's slightly different. So what we have here is a B-17, obviously, but I've broken down the aircraft into both the probability to hit, which is the P hit, and the probability to kill the aircraft. Now, this is really wishy-washy. Most of the time it is. This was originally described to me for tank survival and eventually for weapon system analysis, but this works for everything. But the numbers up there, they need a little bit of explaining as to why they're significant. The first thing we have here is the aircraft as a whole. Since we're discussing any hit on the aircraft, the probability of hit is 1. Ignore the probability of kill for a second. I want to show you how it's computed, but that is the general probability. Based off of, in theory, this should be done for every weapon system that would have been used against it. I think the 8mm Mauser was still used in aircraft at the time. 20mm cannon, flak, a direct hit from an 88, any number of things. This right now is a massive abstraction based off of generally what a strike on the aircraft would do. Now, this is actually, I believe, a variant, not the photo, but what I'm looking at is actually a variant from the Pacific Theater. It has the additional removable fuel tanks in the wings. Now, they're self-sealing, they're very safe, but I needed fuel tanks in the wings to properly show people just this generalized thought process here. So when we break it down, if we're talking ground fire, then the wing is approximately 2/3 of the total area. I'm ignoring the tailplane at this time. I want to simplify things. I didn't want too many branches on the diagram, the tree on the right. So, taking a look, you've got about 2/3 of a chance to hit the wings, and then 1/3 to hit the fuselage. Looking at it now, I think I might have actually overestimated the importance of fuselage, but whatever, we're running with it. Now, the wing is made up of the engine, airfoil surfaces, and fuel surfaces, which are underneath airfoil surfaces, I understand. But basically, if something hits the wing, it's going to hit the fuel, it's going to hit the engine, or it's going to hit a purely airfoil surface. Now, the airfoil surface on a wing is very important. That's why it's its own particular section. You take a look at the fuselage, most of the casualties you'll see, going back to the previous video, is deaths in the aircrew, being the pilot, the co-pilot. The gunners don't matter for the survival of the aircraft per hit. Obviously, the gunners protect the aircraft actively, but without the pilot, the co-pilot, without somebody who can fly the aircraft without functioning controls, nobody survives. There's no two ways about it. We also saw that it's probably further back than the waist, but basically the tail, right before the tailplane, is a vulnerable area. The wing area is very heavily built up, the tailplanes are fairly heavily built up, but all the stress between the two goes through that waist. and any sort of massive damage in the area will kill the aircraft. If you take a look at the percentage to hit for the fuselage, I only have 35% of hits to the fuselage even having a chance to kill anything. The P hit for all of these, if you'll notice, the engine, the airfoil, and the fuel add up to 1. That is the percentage to hit in the wing, not the percentage to hit the entire vehicle. So, taking a look at all of these things, you see that the aircrew are very vulnerable. They're small. You only have a 10% chance of hitting them if you hit the fuselage, but if you put a large caliber round, 20mm explosive round was generally what I was considering here, you're going to have a pretty good chance of injuring or killing the crew. Now you have a pilot and a co-pilot, so you do have to injure or kill 2 people, but between damage to the crew compartment, injuries, if you put a round into the cockpit, it's going to be very dangerous for the survivability of the aircraft. The waste, on the other hand, probability of a kill 0.055%. Roughly 20 rounds in the area to make it not flight worthy. I figured that was, again, a very broad suggestion. These are not meant to be numbers to be used in service. This is meant to be for a planning and assessment. Fuel, about a 10% chance. They are self-sealing tanks. With the exception of starting the vehicle on fire, all you're going to do is make one of the tanks bleed out. If it's not sealing, if it's not on fire, it can be turned off from the cockpit. Now, it might mean you need to ditch the plane sooner, but the plane will still be active so you can make a powered landing, which makes a tremendous amount of difference. Airfoil hits down to 1%. You need to remove a lot of material, or very precise pieces of material, to knock an aircraft out of the sky, losing small bits of airframe. Larger shells, in researching this, I saw a picture, a direct hit from an 88, which, removed the entire wing, but that's an artillery piece. The 88s are terrible things. First off, they have a large enough muzzle velocity that they can get up to this range, but they're also artillery pieces. If those detonate anywhere near the aircraft, they can be damaged. If they do contact detonation, there's almost zero chance of surviving. These are made of aluminum, thin aluminum. They're not designed to shrug off artillery. Remember, even tanks at the time would have trouble with a lot of the 88 armor piercing, and if anything, any of their HE rounds got inside the armor, that was the end. Sorry, a little aside there. Probability hit for the engine is approximately 10%. And, again, I'm being wishy-washy here. I could have measured everything, but this includes the engine, the support structures behind it, and approximately a 10% chance to kill. The reason why it's a 10% is you can lose an engine and still probably limp home. 2 is about the limit. If you lose 3, you can still limp on that one engine and make a powered landing. But generally speaking, not every hit is going to destroy the engine. If it sets it on fire, that's a problem. So if you crack the engine block, these are radials, aren't they? I don't remember if they're radials or pistons. If you destroy whatever the piston rides in, be it the cylinder housing or a block, it will end up either seizing or starting on fire, or otherwise just not functioning, destroying the propeller. The engine ceases to function. Cracking a header might not destroy the engine. Exhaust might not destroy the engine. There are multiple things that will allow you to limp along, maybe not destroy the engine entirely. As such, it's not... A strike to an engine isn't necessarily a loss for the engine. They're very delicate, comparatively speaking, but they're really not terribly problematic as far as the entire airframe goes. But here's where we first took a look at the actual probabilities of a kill. Now, if you multiply the probability of kill by the probability of a hit, you get the probability that any given round in that area is going to cause you a kill. which is when we move back up here to the wing and the fuselage. The wing is the weighted total of all the probabilities of the kill, and the probability of the hit, which gives you a P hit and P kill for the wing. Same with the fuselage. Now, if you take a look, a strike on the fuselage here is much more likely to cause a death. A vehicle kill. And we'll get to the deaths in a minute. But they're roughly equal, a wing or a fuselage hit, based off of just general. You're going to get more wing hits. And that brings us down to, once again, a probability to kill of approximately 10% across the entire aircraft. Now, looking at the aircrew again, probability to kill 20%. You put a round in the aircrew, 20%. Now, if we armored that, if we went with the concept of the A-10 Warthog, I'll get to why in a second, and put a titanium bathtub around it, certainly not World War II technology, but if we reduce the casualty risk of the aircrew to 5% instead of 20%, you will end up getting a much lower fuselage probability of kill and almost have the probability to kill the entire aircraft. Now, I've heard some complaints regarding, the gunners and such weren't protected, and it's problematic. It is problematic that, yes, the gunners were not protected. Their lives were not valued quite as highly when it comes to armor protection. But if a gunner dies or is injured, the gunner is injured or dies. And as far as a human loss, that's a tragedy. If the aircrew dies, everyone on the aircraft dies. So by protecting 2 people, you're protecting 10. Now, you can't armor every crew station. If you did, it would no longer be a bomber. It would basically be something that flies around and gets shot at by fighter aircraft. But if you need to keep 2 people alive, it is the aircrew. It's much more vulnerable without the gunners, but the gunners live only if the aircrew lives. Just to further break down with what each individual thing means before I move on. If you take a look here, here's our fuel probability to hit and probability to kill from earlier. I just wanted to run this down. This is more what you see in like industrial engineering. The fuel itself requires certain steps. If the fuel line is broken, and I don't have probability to hit or kill with any of these because it's just not worth it at this stage. I don't have strong enough numbers, it's not worth running them down. But it means the engine line, the fuel line between the fuel pump and the engine, if that's gone, nothing else matters. The fuel pump, if the fuel pump is gone, nothing else matters. If the pump line or the pump power are out, nothing else matters. If the fuel tank is out, nothing else matters. So, the fuel is made up for the risk to the line, plus the risk to the pump, plus the risk to the pump's power or its feed lines, plus the fuel tank. If any of those break down, then fuel is off entirely. Now this means if you have redundant systems, redundant fuel lines, redundant pumps, redundant power supplies, then you have to determine that both of them are gone before the risk increases. This is why redundancy is so terribly important, is now, if you have something that's 90% efficient, if it fails and you can fix it, it doesn't matter. If it's 90% reliable, and you have 2 of them, that means your expected reliability is 99%. Because in the 10% that one fails, The other one will still have a 90% reliability rating. The numbers are a little different, a little more flaky, a little stranger. But generally speaking, that is what it is. And this is an image that I made a while back. I'm actually quite fond of it. And I really need to fact check the. I believe that is the approximate payload of the vehicles. Two B-17s and one A-10. The A-10 has jet engines. Okay, let's not beat about the bush here. It's also, what was it, introduced in the 70s, 80s? It's decades newer. It has jet engines. The A-10 is built for reliability and survivability. It has two separate hydraulic systems. It can lose about a quarter of its airfoil before it falls out of the sky, half the tail. One of the engines. The engine's designed to rip entirely off and not be a mission failure. The air intakes are above the wings, so they're protected from ground fire. The pilot is protected by armor plating. It's basically a gun with wings and engine strapped to it. It is an incredible airframe. And if you take a look at what we have here, the probability to hit a B-17, we've set at 1. The A-10 is approximately 1/4 of the area. We'll call that 0.25. Probability of a kill, B-17, let's take the original, 0.09. Let's assume that the A-10 is like the B-17 with cockpit armor. It's down to 0.05, right? Very similar there. Let's just run with it. Makes the survivability of a B-17 roughly 83% and an A-10 95%. We're not saying that every A-10 that goes out has a 5% chance of falling out of the sky. What we're saying is comparatively, the chances of losing an A-10 are substantially lower versus a B-17. The probability of losing one aircraft for an A-10 is about 1%. You can't lose two aircraft, we're only sending one. Probability of losing one B-17 is 9%. The probability of losing both on a mission is approximately 8%. What you have to do for there is you have to take the survival and you have to figure out the chances of survivability for one or both aircraft. I'll actually play out the math one of these days, but this one's gone on long enough. But what this means is each B-17 carries 10 people. The A-10 carries 1. You lose an A-10, 1% chance, you will lose a person. That means the risk to human life we've determined is 0.01. If you lose a B-17, you lose 10 men. Therefore, when we have 0.17, 17% chance of loss, you're looking at 1.7 as a risk to human life. You are discussing 170 times greater. Is that right? And this is why you take a look at your numbers before you make a presentation, I'm just saying. But you're talking about 170 times greater risk of life. Because B-17 is 17 times more likely to go down when you have two of them in the danger zone over one A-10. And every one that goes down causes 10 times the casualties. Yeah, that actually does work. This is the sort of thing you need to take a look at for risk assessment. Even if the A-10 was more prone to risk, it would have to be 10 times more dangerous with just a pilot to equal out to having 10 people at risk in the air crew. It's a simple matter of statistics, and it's just one of those things that really undermines what risk is looking at. We are looking at keeping people alive. That means we have to worry about both the situation and the number of people involved in the situation. And I will get to all of that math some other time, because I'm worried that it won't interest me, much less interesting you. But, once again, this is Michael Farragut from Between the Borders. If you have any ideas, anything you want to see for risk analysis, intelligence, please let me know. I I'm always constantly running low on ideas, but then one will pop up and I'll make a video that day. So I'm afraid I don't have much of a schedule for you at this time. If there's anything I can do for you, please contact me, betweentheborders.com, through this YouTube channel, my Facebook. I certainly hope my Facebook contact information is on this channel as well. And of course, if you're interested, feel free to check out my book, American Insurgent. It covers the information available to those who would believe in insurgency in the U.S. today, and the general main thought processes of each of those, and what we'd expect if anything did happen. Thank you very much. Please stay safe.